This is our second day in quadratics. Today we're going to be talking about writing quadratic equations in different forms. So if I want to write the equation for the parabola in vertex form, we know the vertex is given as 50, 35. So we can have x minus 50 squared plus 35. But the problem is we still have an a value here. So we need to know what this a value would be. In order to do that, we can take any other point that's on here, and they gave us the point 0, 15, and we could plug the 0 in for x and the 15 in for y, right? Put them in to the x and the y, and then we could solve it for a. So if I were to do that, oops, already did that wrong. We're going to replace the y with 15. We're going to replace the x with 0. So I have 15. I'm going to get rid of this 35 right away. Minus 35 from both sides gives me negative 20. This 0 minus 50 is negative 50. So negative 50 squared is positive 2,500. And I'm going to divide both sides by that 2,500, and that actually reduces the negative 20 over 2,500 is negative 1 over 125. So I'm going to rewrite my equation now. So it should have been y equals negative 1 over 125 times x minus 50 squared plus 35. That is the equation in vertex form for this parabola. Identify and interpret the max or min. So when they say that, we should be using the words that they've shown us in the graph. So they talked about the fact that this is a human cannibal. The y value represents the height in feet. The x value represents the the distance in feet, the horizontal distance. And we could see that this had a high point, a max point. So I'm going to try to include the scenario I'm dealing with, if it's a max or min value, what the y value is in context, and what the x value is in context. So what I could say is the human cannonball so it reaches a max height of, so we got up to 35, and that was in feet. And that's after they've traveled 50 feet. And that is our interpretation of the max or min point. So there's another one we're going to do, and we want to do this one in intercept form. So we're going to have to follow the same steps. We know the intercept form would be y equals a times x minus one intercept, so that's 4, times x minus the other intercept, which was 24. Again, we have the point 0, 9.6, so if I put that 9.6 in for y and 0 in for both x's, I have 9.6 equals a times negative 4 times negative 24. So negative 4 times negative 24 is 96. And if I divide both sides by 96, I actually am left with 1 over 10. So that tells me my equation will be y equals 1/10 x minus 4, x minus 24. So now we want to identify and interpret the zeros of the function. So the zeros of the function are when y equals 0. So the zeros of the function are when the temperature is 0 degrees. So we want to talk about the x values when the temperature is 0 degrees. So I'm going to say the temperature is 0 degrees. And this is Celsius. And it's going to be that number of hours after midnight. So 4 hours after midnight would be at 4 a.m. And 24 hours after midnight would be the following midnight. I knew that looked wrong and I thought it was on the N, but it was clearly on the D that I wrote as a G. Okay, there we go. That looks better. Or we could say at 12 a.m. So now example 3, we're going to use the same picture for a bunch of parts here, right? So we start with A and B. So here's our equation, 1 over 20 times x squared minus 1x plus 12. And f of x, or the y value, is the bird's height above the ground, and x is the horizontal distance traveled, and both of them are measured in feet. So the domain of the graph, what they've drawn, does not go forever. It starts here, and it ends here. So my domain is actually going to start and stop. It's going to start at x is 0, and it's going to stop at x is 25. So we're going to say, because these numbers are included, from 0 to 25. What is the range of the graph? So the very lowest that it went, was when y was 7. So the bottom of our graph is 7. And the very highest point I see is up here at 15, 16, 17, 18. All right, so that's because our graph did not have any arrows on it. Part C, what is the y-intercept? So the y-intercept is where it started, right? Where it crosses the y-axis. So that is at 0, 12. And also, if we looked at our standard form equation, right? Standard form tells us the y-intercept. We could have looked at the function there. Part D, it says rewrite the function to represent vertex form. So this shouldn't be bad because we already know what A is, right? A in the standard form is 1 over 20. We could see that the vertex is at 10, 7. So that's going to be x minus 10 squared plus 7. Part E, which of those forms, standard or vertex, would show you how low the bird flew? So that would be vertex form, right? The vertex form shows you the vertex, which allows you to know the min or the max. And it says identify the interval the bird is increasing in height. So we start increasing here, right? This is when it starts to go up as opposed to down. So it's going up, starting at x is 10 until 25. But we're not going to include the 10 because remember, we're staying still at 10. So from 10 to 25 is when the bird was increasing in height. So here's one for you to try. All the parts are on this page, so you can see them all. You can pause. The answer is posted in the blank notes in Google Classroom. So finding the vertex from the different forms. When it's in vertex form, right, it's just the h comma k, right? Vertex form was a x minus h squared plus k. So h comma k is the vertex. In intercept form, which started as x minus p times x minus q, we're going to take those two intercepts, the p and the q, and we're going to average them. We're going to add them up and divide by 2. We're going to find the middle. And after I find the middle, I then plug it back in. Right? So once I have x, I put the x's into both of those and solve this side to get out what y is. Standard form, which we know is y equals ax squared plus bx plus c. For the x, we're going to do negative b divided by 2 times a. And then once I know what the x is, again, we plug it back in to get the y. So for example 4, a is written in vertex form. So in vertex form, we just take our two numbers, inside's opposite, outside's normal, negative 3, 7. And then the axis of symmetry would be through that x value, x equals negative 3. For B, this is standard form. So standard form, right, we're going to take the the B, right, negative B over 2 times A. So this is going to be a positive 5/2. So our axis of symmetry is x equals 5/2 or 2.5. However you'd prefer to write that is fine. But we still have to plug back in to find the rest of our vertex. So that's going to be a negative times, I'll put 2.5 squared plus 5 times 2.5 minus 6. So this is negative 6.25 plus 12.5 minus 6, which overall turns into 0.25. So this is going to be for our vertex 2.5, comma 0.25. For our last one, that's intercept form. So remember, intercept form, we take the p and the q. That's positive 4, positive 8. So x will be equal 4 plus 8 over 2. 12 over 2, x equals 6 is our axis of symmetry. And then I'm going to take x is 6 and put it back in. So 6 minus 4, 6 minus 8. That's a positive 2 and a negative 2. If you've done this right, as long as you got the correct x value, you should get the same thing, but different signs here. So this is y equals negative 4. So this is going to be 6 comma negative 4 for my vertex. X equals 6 is my axis of symmetry. Example 5, we now have a word problem. The path of a diver can be modeled by this function, where f of x is the height of the diver in meters above the water, and oops, that should say y is the horizontal, or f of x is the horizontal distance in meters. Oh no, that was right. F of x is the height, x is the horizontal distance. I can't read my own stuff. First of all, find the height of the diving board. So this is the initial point where they're jumping from. So that would have to be what the y-intercept was. The y-intercept was 1. So the height of the diving board is 1 foot. Right? If you want to make a note for yourself, that's because the y-intercept equals our starting height. What is the maximum height the diver reaches? So that would be the y value of the vertex, right? Y value of the vertex. And this is not written in vertex form for us, so we will have to do the math to find the vertex. So we have a b that's 9 and an a that's negative 9. So if we're going to do negative b over 2a, that's negative 9 over negative 18, which is 0.5, right? 1/2. So if I put that back in, y is equal to negative 9 times 0.5 squared plus 9 times 0.5 plus 1. So this is not negative 9 times 0.25, so that's negative 2.25 plus 4.5 plus 1. So that comes out to be 3.25. So what is the maximum height the diver reaches? Reaches a max of 3.25, and they said everything was in feet, right? Oh, look at that before. This was in meters, and I gave the wrong units for that as well. Meters. Meters. Example 6. The parabola shows the path of your first golf shot, where x is the horizontal distance in yards, you've got to remember that now, and y is the corresponding height in yards. The path of your second shot can be modeled by this function. Which shot travels farther before hitting ground and which travels higher? So the first part, which shot travels farther, so we're talking about what are the x values when it's on the ground. So what are the x-intercepts? So for my graph, The x-intercepts are 0, 0, and 100, 0. So that means it traveled 100 yards. So shot, they're calling it first shot and second shot. So first travels 100 yards. My second, it's written for us in intercept form. So this is 0 and this is 80. So it went from 0 to 80. So the second shot went 80 yards. So which shot travels farther before hitting the ground? The first shot travels farther. For the second one, it's asking which one is higher. So that's the y value of our vertex. So here we have the vertex graphed for us, and the y value is 25. So the first one reaches 25 yards. The second one, we're going to have to do some math for. So first things first, we need our x value. So we take the 0 and the 80, add them up, divide by 2, so x is 40. And now we're going to plug that back in. So negative 0.02 times 40 minus 80. So 40 times negative 40 is negative 160 times that negative 0.02 is 32. So the second shot reaches 32 yards, which means the second shot travels higher. So here's one for you to try. You can pause. The answers are posted in the blank notes in Google Classroom. The last thing we're going to do is actually the trickiest thing on here, and it's rewriting it from standard form into vertex. What we're really trying to do is a process called completing the square, and we're going to talk much more about completing the square later on when we talk about solving quadratics. There will be a problem like this on our TCA, so I want to make sure that we've seen it. So the way we're going to just do it, and there's many ways you can look at this. This I think is the most streamlined, but if you know another way, that's okay. You do you. We're first going to factor out the a value. So that way we're not looking at the original b value they gave us. We're looking at a new b value. We want the new a to be 1, essentially, and b to be unaffected by a. So if we're taking it out, we're going to take half of b, whatever sign it was, is going to go inside the parentheses that's squared. And then we're either going to add or subtract that original a value that we took out times this number squared. It sounds so complicated. It's not terrible. Whatever this a value was, whatever the sign was, we're going to do the opposite there. So here, an object's path can be modeled by this function, where h is the height of the object and x is the horizontal distance, both in feet. Write a function that reveals the maximum height of the object. So the first thing we said we're going to do is take out the a value. So if I had 5x squared minus 80x, 5 is the a value. So if I divide both these by 5, I'm now left with x squared minus 16x. So now the b value is really negative 16, right? B is really negative 16. So I need to do b over 2. So negative 16 over 2 is negative 8. And I need to have that squared as well, which would be a 64. So it's going to be a times parentheses x plus or minus that b over 2 value we just got, and then plus or minus the a times that squared value we just got. So that's going to be a is 5, x minus 8 squared. This was a positive 5, so now we're going to do a negative 5 times the 64. And I'm actually going to do the negative 5 times the 64 to finish out my problem. So this would be the equation that shows us the vertex. Now, certainly you could also instead find the vertex of this function, right? Do your negative b over 2a, plug it in, find out what the y would be, and then rewrite it, just making sure that you have the a there. That's another way to do this. Nothing is stopping you from doing it that way, right? But this is the way that I'm showing it. This is the way I'll probably do my work, just so you see more than one way. So here's one for you to try. You can pause. Answers are posted in the Google Classroom, but this is also the end of writing quadratic equations.